Hi viewers, this is second part of coordinate geometry. So we will discuss about reading scales, and then in this video you will learn about gradient, how to find gradient when we have 2 points are given. It even it is either it is slopy line or we have horizontal line or vertical lines. And when gradient is positive or negative, that we will see also. So first point is reading the scale. If you see the first question of 21.4, the points A, B, C are not at whole numbers, points on the number line. So point A is at 0.7. So they mentioned already the point A. Remember that from 0 to 1, we have how many boxes of small square? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means scale, we can say that one small square is equal 1 divided by 10. Because 0 to 1, we have small 10 squares. So that would be equal to 0.1, means 1/10. So each small square equal, a big square equal 1 and small square equal 1 by 10. Okay, that gives us 0.1 or 1/10. So each small square is equal or box equal 0.1. So they already mentioned the point A answer, which is 0.7, or you can write here 0.7. If we check B is after 1. After 1, how many boxes or squares we have? Small. 1, 2, 3, 4, 5. So this is 1.5. Same as we will try to find out C, which is after 2, 1, 2, 3, 4. So that means 2.4. If we check 3, lastly we have to check D, which is after 4. So, and before 5, 2 boxes, so 4.8. I hope so you understand. We find it all. We try one more question related to reading scale. See or have a look. This question number 2 on this number line. Point E is 0.4, and what are the positions of point F, G, and H? So first of all, we will see from 0 to 1, we have how many boxes. So if you try to make scale first, that will help us. So one big square equal 1, and one small square represent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 more. It means 20 small boxes. So one small square is equal 1 divided by 20. So if we check 1 divided by 20, that is equal 0.05. So if you check E, which they already mentioned, it is 0.4. We can straight away check, like we have how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. So for point E, we can say that 8 multiplies 0.05, which gives us exactly 0.4, and it is given as well. Now what is the point EF? So for point F, we have 18 boxes, because 0 to 1 we have small 20 boxes. So before 1 we have 2, so that means it represents 18. So if you check our another point, 2 boxes equal 0.1. Okay, remember this. Here we have two ways to find position F. Either 18 multiplies 0.05. So this would be equal 0.9. So here you can say that 0.9. Are each two boxes equal 0.1? Okay. So here you have exactly 0.5. So here 0.6, 0.7, 0.8, 0.9. You can find like this way also. Same as G is after 1 and between 1 and 2. So we can straight away say that this is 1.5. And after G, we have how many boxes? 1, 2, 3, 4, 5. So each two boxes equal 0.1. Means here we have 1.6, 1.7. So 1.75. 1.75. I hope so it is clear for you. Now, in this question, give the coordinates of points A, B, C, D, E, F, G, and H represent these two-dimensional shapes, which represent horizontal x-axis and vertical y-axis, which is bottom to up and left to right horizontal x-axis. So we already know in the previous video, 0 to right we have positive values, 0 to left negative values, 0 to up positive y values, and 0 to down we have negative y values. Only you come to know what is scale, so that will help you to recognize the position of A, B, C, and D. Here, scale along x-axis, because here you have two. Scale along x-axis, we have one small square equal, again from 0 to 1 we have 10 boxes, so each one small box equals 0.1 or 1/10. Same as scale along y-axis, we have 0 to 1 same way, 5 and 5, 10. So 10 small boxes, so same scale along y-axis as well, means 1 over 10, that gives us 0.1. So now it's easy for us to give the answer of A part first. A part we have 1 unit right and up 1.5. It is exactly middle between 1 and 2. Okay, so 1 comma 1.5. Same as if you try to find out B, so it is 1 point. Remember, each one small box equal 0.1. Okay, so this is after 1, 2 small boxes. If you go, yes. So 1.2 along x-axis, 1.2, and along y-axis, if we straight away go down, it is exactly between -1 and -2. That means -1.5. If we check point C, this one along x-axis, it is 1 point behind -1, so that is -0.9 along x-axis, and down it is not exactly between -1 and 2, it is down, yeah, 6 boxes, so we can say that -1.6, not 5. And D along x-axis, it is here you have -1.5, so 0.6, 0.7, 0.8, so it means -1.8 up. We have here exactly 0.5. This one is exactly 0.5. So from 0.5 to up, we have two boxes. If you check carefully, 1, 2 means 0.7, 0.7. So these are the points we write it all A, B, C, D. I hope so you understand. If we check the second one also, for example, you must know what is the scale first. So if you check the scale for second, we have 0 to 1, it's 5 boxes, okay? So this is scale along x-axis. We have one small square equal 0 to 1, 5 boxes. So it means 1 divided by 5. That gives us 1 divided by 5, that gives us 0.2, means each small box equal 0.2 along x-axis, and along y-axis is also 0 to 1, we have 5. So same along y-axis, 1 small square equal also same 1 divided by 5, which is equal 0.2. So if we try to find out the first point, which is Let's suppose E. So E is exactly 1 unit right. So we can say that 1 comma up. It is every small box, each small box equal 0.2. So here it is 1 point behind 2. That means 1.8 along y-axis. So if we check H part along x-axis, it is we can say that here exactly here we have -1. So this is look like between -1 and 2, but better we count. So here -1.2, -1.4, -1.6. So it is -1.6 comma up. We can check also it is above 3. Okay, above 3, how many boxes? 3 boxes. 1, 2, 3. So that means 3.6. If we try one more point, let's suppose F we are looking. So it is what? 3 exactly right side, and down we will check. It is behind -2, 2 boxes. So each box equal 0.2. Okay. So -2.4. And lastly, we have G. So it is along x-axis after -3. How many boxes? 1, 2, 3. So it means -3.6 comma down it is behind -1, 1, 2, 3. So -1.6. I hope so you understand. Yes, viewers, now we will discuss gradient of straight lines. So straight lines can be slopy or vertical or horizontal. So here you can see the different type of lines. So when you see the line from left to right up, we always find positive gradient. When it is more steeper, that means you will find more bigger gradient as well. And when the line goes from left to right down, the gradient is always negative. So basically gradient or slope is equal vertical distance of y coordinate divided by the x coordinate of uh, along horizontal, the difference or distance of x coordinate along x axis. Here you can see one formula: gradient equal vertical distance between 2 points over horizontal distance between 2 points. So we straight away solve one question from the exercise: how to figure it out gradient, and when it is positive, when it is negative. Look, the line sloping this way will have a positive gradient, and when the line goes from left to right down, sloping this way will have a negative gradient. When it is more steeper, that means gradient is more bigger or larger, that we will see here how to find or figure it out what is the gradient. So the first point is we will take 2 points, any 2 points from this line. As you can see that the line, so I'm choosing any 2 points. For example, this is my first point, which is A, and it is -3 and -2. And second point I'm choosing from here are more bigger. Let's suppose this one is B, and it is 3 unit right and 4 unit up. So I found, or I choose 2 points which are A. A is -3 comma -2, and the second point B, which is 3 comma 4. And remember that the line goes from left to right up, so gradient must be positive. Now, what is the formula of gradient? M represent gradient. Okay, we can say that gradient M, which is equal y2 minus y1 over x2 minus x1. This the formula will work for us. So now I will consider this one x1 y1, x2 y2. So if we replace the value of this gradient, that means y2 minus y1, 4 minus into -2 over x2 is 3 minus into -3. So I'm getting 4 plus 2 over -3 minus minus plus 3. That means 6 over 6, which is equal 1. So over gradient is 1. This is our required gradient. I hope so you understand how we get it. Now we will see one gradient for horizontal case and for vertical case. Let's have a look. This one also positive gradient. Here you will find negative gradient. Okay, we try one for negative. If I choose any 2 points from this line, For example, one point is here. Let's suppose this point is A and it is -3 and 3 unit up, and one point, it's better we choose it as integers, okay, like whole numbers. That would be easy for us to find out the gradient. For example, I'm choosing this one. This is point B and it is -1, and down is also -1. So let's have a look how to find the gradient. A point is -3 comma 3 and B point is -1 comma -1, and we are looking the gradient. Gradient is equal or represent m, which is equal y2 minus y1 over, remember that in numerator always the difference of y coordinate, which is along vertical sides, okay, and denominator form, in denominator always distance of y coordinate, x coordinate, okay, x2 minus x1. Now if we check what is x2 and x1, those values are here, x1 y1 x2 y2. So if you replace, it would be -1 -3, x2 is -1 and minus +3, so we are getting -4 over 2. That means it is equal -2. So we find out m gradient is equal -2. So remember, when the line goes from left to right down or this way, gradient is always negative. Now the next point is when gradient is 0 or when gradient is undefined. That we will check now. So if you have a line which is vertical, or if your line pass through origin, then your gradient is 1. Here you have, or we have horizontal line. So whenever we have horizontal line, gradient is 0. So we will check how it comes 0, okay. For example, we choose any 2 points from this line. Let's suppose one point is here, which is A, -2 -1, and one point is here, which is B, 4 along x-axis and -1. So I have these points. The points are A, which is -2 and -1. B is 4 comma -1. What is the gradient? Gradient, what we are looking, formula is y2 minus y1 over x2 minus x1. So we can say that it is, this is x1 y1 x2 y2. So here y2 is -1 and y1 is -1, but 1 minus in the formula, over x2 4 minus into -2. So we can say that -1 minus +1 over 4 plus 2, which is equal 0 over 6, which is equal 0. So when you have horizontal line, we always gradient is 0. Here you have the line y is equal to, look, the here value of y is fixed, yes, -1 and -1. If you want to write the line of this, it is y is equal to -1. That is the line. Now because it passed through -1 and -1 is fixed in all these coordinates, and the gradient is 0. I hope so you understand. Now we move on one vertical line, and in that vertical line we say the gradient is undefined. We are not able to find the gradient. Let's have a look. Let's have a look. One vertical line. This part we will check what is the gradient here. So if we check gradient, for example, any 2 points, one point is here, which is, let's suppose A, it is 2 no 3 along x-axis and 2 along y-axis, and one more point, we can check the last, no problem. B, it is 3 along x-axis and y -4. So now what is the gradient? We will check here. A is 3 comma 2 and B is 3 comma -4. So we are looking the gradient, and gradient m formula is y2 minus y1 over x2 minus x1. That means here we have x1 y1 x2 y2. So we have -4 -2 over 3 -3, And if you check minus 4 minus 2 gives us minus 6 over 0. So anything divided on 0 gives us infinity. It means when you have vertical line, this is vertical line, and in this line x is fixed, that line is x is equal to 3, and the gradient is what? Gradient is undefined. Gradient is undefined. We are not able to find the gradient, means it is infinity. I hope so it is clear when gradient is positive, when it is negative, when gradient is 0, and when gradient is uh, undefined.